Topic 11, Transformations and Point and Line Symmetry. Pre-image, the figure before a transformation. Any picture will do. The image, the figure after a transformation. You'll start with your pre-image and transform it. Map, the rules on how a pre-image is transformed. In our pre-image to image example, the triangle was translated right 6 spaces. We can also write that as x plus 6, comma, y plus 0, because it did not move up or down. Our types of transformations are translation, that is to translate a figure up or down, left or right, without changing its orientation. The slang term is to slide the figure. So we'll take our triangle and slide it. This triangle moved 1, 2, 3, 4, 5, 6 spaces to the right and 1, 2, 3 spaces up. Right is positive and up is positive, so I'll describe this as x plus 6 and y plus 3. We can also reflect. To reflect a figure across a line, creating a mirror image of the pre-image. Our slang term will be to flip the figure. Starting with a different triangle, we're going to flip it across our line. When we have a line, we'll count straight down to it. 1, 2, 3, 4, 5. And the same distance down to the line is the same number of spaces we'll count over. 1, 2, 3, 4, 5. We'll do this for every point. We would call this reflection, reflected across the line, y equals x. Lastly, we'll have a rotation, to rotate a figure around a point of rotation. Our slang term will be spinning the figure. We'll start with a triangle, and we will spin it around the origin, rather. So if we imagine one point on the triangle, 3, 3, when it gets rotated 90 degrees, negative 3, positive 3 becomes positive 3, positive 3. It was rotated 90 degrees clockwise. Among the types of transformations, the last one will be a dilation. A dilation is to multiply the side lengths of a figure by a scale factor to create a similar image. In a slang term, we will be stretching or shrinking the figure. So, given right triangle A, we're going to dilate A by a factor of 3 halves. Each xy ordered pair is thus going to be multiplied by 3 halves. So if we take the 0, negative 2, for example, when we dilate it by 3 halves, it will now be located at 0, negative 3. 0 times 3 halves is 0. Negative 2 times 3 halves is negative 3. Here's what it'll look like in pictures. So we stretch triangle A until it's 3 halves larger than it was before. Types of symmetry. There is line symmetry. The line of symmetry is the line which the figure is reflected across so that the image matches up with the pre-image. For instance, on your notes you see half of a sun. If this sun figure had line symmetry, then the other half of the sun could be drawn. Notice that the 2 halves are the same. They were reflected. Point symmetry. A figure is rotated exactly 180 degrees and matches the pre-image. For instance, the letter H, when we rotate it 180 degrees, forms the exact same letter. To see another example, I can take a playing card and rotate it 180 degrees to get the exact same picture. Here are some examples. Here are some examples. Triangle A prime, B prime, C prime is. That is, we have pre-image ABC and image A prime, B prime, C prime, and we want to know how I get from one to the other. Is it F, a translation across the y-axis, G, a 90 degrees clockwise rotation about the origin, H, a reflection across the y-axis, or J, a reflection across the x-axis? Well, a translation means that it could be slid. We could slide it onto its image. Rotation means we would have to spin it to get it onto its image. A reflection has to be flipped, and again we see reflection, which means to flip. So I'm going to imagine this triangle, A in the left-hand corner, B in the right-hand corner, and C in the bottom. I can see that if I just slide it onto the image, it's the exact same thing. A lines up with A, B lines up with B, and C lines up with B. Also, it slid across the y-axis, which matches F perfectly. It was a translation. It slid across the y-axis. F is my solution. The polygon A prime, B prime, C prime, D prime, E prime is a translation, a slide across the x-axis, a 100 degrees clockwise rotation about the origin, or a reflection across the y-axis, a reflection across the x-axis. So, to start with my pre-image, A, B, C, D, E, let's see if it is a translation across the x-axis. So we'll take our shape and slide it down, and it just does not match up perfectly. So it cannot be a translation. Let's check a 180 degree clockwise rotation about the origin. So we'll still take our A, B, C, D, E, and now we're going to rotate it 90 degrees, and then we'll rotate it another 90 degrees to get our total 180 degree rotation. This does not match our image, so it cannot be our solution. Let's check C and D. So either it's going to be a reflection across the y-axis, or it'll be a reflection across the x-axis. Because my figure is below it across the x-axis, I'm pretty sure that's where my reflection will be. But let's check. So I'll reflect my shape, and it matches perfectly when it goes across the x-axis. So my solution is that pre-image A, B, C, D, E gets reflected across the x-axis. Which of the following is a dilation? A triangle ABC, given in the picture, with center of dilation 0, 0. Well, when we think dilation, we're really looking for a scale factor. So, let's get the ordered pairs of A, B, and C. In the picture, we see that point A is at -5, 4. Point B is at 8, 6, and point C is at 4, -5. I know it's hard to see, but there is a letter C underneath that dot. We will now see if there's a common scale factor in each of the multiple choice options. For example, let's look at option A first. So to get the scale factor, we'll take each x and divide it. So from A to A prime, we'll take -5 divided by -2.5. And we see that that scale factor would be 2. Now let's take the y values of A and A prime. 4 divided by 2, and 4 divided by 2 is also 2. So far so good. Now let's take our x values for B. If I take 8 divided by 8, I get 1. Because we do not have a common scale factor, I know that option A is not going to be correct. Now let's compare it to B. So B has an A prime of -5/3, 4/3. It has a B prime of 8/3, 2, and a C prime of 4/3, -5/3. So to get the scale factor, we'll again take each x and y of the corresponding points and check for their scale factor. So the x's of A and A prime divided, -5 divided by -5/3, evaluates to be +3. Well, if we take the y values of a and a prime, 4 divided by 4/3, that also evaluates to 3. Now, let's look at the x terms of b divided by b prime. So 8 divided by 8/3 would also simplifies to 3. And now the y values of b and b prime would be 6 divided by 2, which is 3. With c and c prime, we'll take x divided by x, 4 divided by 4/3, which simplifies to 3. And negative 5 divided by negative 5/3. Excuse me, I did miswrite. Negative 5 divided by negative 5/3, which also simplifies to 3. In this way, I see that B will be my solution. For the following images, determine whether the image has point symmetry. That is, I can turn it upside down and it is the same. Line symmetry, I can draw a line and the two pieces are identical, they're reflected. Or if it has both point and line symmetry. Otherwise, it will have no symmetry. So starting with my arrow, I see that I can draw a line of symmetry. The top half could be reflected across the line to create the bottom half. So it does have line symmetry. When I rotate my figure 180 degrees, I see that it does not match up perfectly, so it has no point symmetry. For the next shape, when I draw the line, I see that that top half is not reflected onto the bottom half. It does not have line symmetry. Try a couple other lines. See if you can fold it to have a reflected line. When I take the same shape and rotate it 180 degrees, that is, I turn it upside down, it is the exact same shape, so it does have point symmetry. For my last shape, there is no line that I can draw where this shape will be perfectly reflected. And when I rotate it, it is not exactly the same, so it does not have point symmetry. The last shape will have no symmetry.